right, so here's a pretty straightforward example of dealing with power when we're looking at torsion in shafts. So we have a solid 40 millimeter diameter, wrote that down, shaft. It's rotating at a speed of 560 RPMs. So really this is omega equals 560 RPMs. In our equation, we can write RPMs as N. So I think I would change this and write this. So, yeah. Omega equals 560 RPMs. And it has this maximum shear stress of 85 megapascals. And we're supposed to determine the power in kilowatts that's being delivered by the shaft. Okay, so what does power equal? Power equals the torque on the shaft times the omega, the speed at which it's rotating. And we developed in class this handy equation. So we can write this as T. Let me write it different. It can be T times 2 pi. That stands for, that is 1 revolution, times N. That's where we plug in the number of revolutions per minute, divided by 60. So all this equation does is that 60 is because we are change minutes to seconds. So this equation just does all your converting of RPMs to revolutions per second, because that's what we use in omega. So, and then we're supposed to determine, we need to find, we know the power. No, we need to find the power. So, but first, we need to find the torque. And we can find the torque, because we don't know the torque, we can find the torque using this maximum shear stress that they told us. So, we also know that shear stress, the max, so at the outside, equals the torque times the maximum radius all over the polar moment of inertia. All right, so we're going to solve that for T. So we'll get T equals tau max times J divided by C. All right, so we need to find J. J equals pi over 32 times the diameter to the 4th. So that equals pi over 32 times 40 millimeters to the 4th. So that is 251,327 millimeters to the 4th. C is the radius, so C equals the diameter over 2, which is going to be 20 millimeters. Now we can solve for the torque. So the torque equals shear stress max, which is 85 megapascals, so that's newtons per millimeter squared, times J, 251,327 millimeters to the 4th, divided by C, which is 20 millimeters. And we get a torque equal to 1,068,142 Newton times millimeters. All right, so then the power is we're going to write this first as T equals 1,068 newtons times meters. All right, so next we can take, now we can find the power. So we have torque, we know 2 pi, and we know N and 60, so all we needed was torque to find the power. Okay, so, and we're supposed to, the power in kilowatts. So we have power equals, we're using this equation now. Power equals the torque, 1,068 newtons times meters, times 2 pi, times N, 560 revolutions per minute, all divided by 60 seconds. So we get power equals 62,639 newtons times meters per second. And guess what this is? That is a watt. So this equals 62,639 watts, but we're supposed to give it in kilowatts. So power equals 62.6 kilowatts. All right.